So, we've learned how to work with promises using callbacks, how to consume the data, handle errors, and clean up at the end no matter what the outcome is. As we've mentioned, the main issue with the approach we showed is that it's based on callbacks, and callbacks can get really messy. We saw some examples of how complicated callback-based code can get. So much that it is named the callback hell. Now, think about something even more complex, like trying to run a loop that starts with one asynchronous action and ends with another. How would you even do that? After all, a callback is essentially another function, and it's nearly impossible to manage something like a try-catch block or while or if or switch if they span over different functions. In this lecture, we're going to look at a cool trick that JavaScript introduced, which lets us write asynchronous code as if it were synchronous. It lets us write code without callbacks while still enjoying that synchronous style where each function runs instantly and keeps the thread responsive and free. So here's how it works. JavaScript introduced a new way of writing functions called async await. The async keyword signals that we intend to use the await inside that function. Simply adding async to a function doesn't change how it runs. It still runs the same way it did before, but async tells JavaScript that we're going to use await inside. When we use await, something interesting happens. If we write something like let p equals getDelayedNumber and then await p, the await keyword effectively ends the function right there. Even if there are more lines of code after the await, as far as JavaScript is concerned, the function ends right there, making it run instantly up to that point. The await keyword can only be used in front of a promise. If you've seen await in front of a function, what's really happening is that the function returns a promise and await is applied to that promise. In other words, first the function runs, then it returns a promise, and only then we await that promise. So we do not await the function, we await the promise that it returns. As you can guess, await makes us wait for the promise to resolve. But the waiting doesn't happen inside the function. The function ends, and the wait occurs outside of it. What JavaScript does behind the scenes is transform our function into something else. It takes everything after the await and wraps it into a separate function, placing it as a callback inside promise.then. So it looks like one log function, but it's actually two instantaneous functions with a pause in between, during which nothing runs and the thread is free. JavaScript is smart enough to handle all sorts of scenarios, like putting this structure inside a loop or an if statement. It compiles everything intelligently so that even though these are separate functions, all the variables from the first half are still available in the second half. Now you may be wondering, what about error handling? Async await also allows us to handle errors using try-catch blocks. If you wrap your await calls inside a try-catch block, the part that's inside the catch block is also transformed into a callback that is registered using the catch method. Similarly, if you use the finally block, that block of code goes into the finally method. That means that async essentially tells JavaScript to transform the function into a structure that uses the then, catch, and finally methods under the hood. In a way, you can think of it as JavaScript having a sort of compiler that translates our high-level async await code into more basic promise-based method code using then. It's important to remember that because of this transformation, even though it looks like one continuous function, there are actually two separate functions running with a pause in between. During that pause, other code can run and global variables can change, so you have to be mindful of that. Each part of the function, both before and after the await, runs instantly and is fully synchronous in itself, but the overall function is split into these two pieces. To illustrate the fact that these functions run in a completely synchronous manner and that the function essentially ends before the await, I want to separate the asynchronous part into a different function. We'll have a regular function called go that a button will trigger, and we'll move all the special logic into another function which we'll call start. The start function will be async, and it will print three things to the screen. It will print start1 before creating the promise. It will print start2 after creating the promise but before the await. And it will print start3 at the very end, after the await. Additionally, in the outer go function, we'll print go1 before calling start and go2 right after calling start. Now, here's a little challenge for you. Pause the video for a moment and try to think about the order in which these messages will appear in the console. If you've guessed that start3 will be printed last, you're absolutely right. Start3 is the only part that gets turned into a separate function that runs later. Everything else runs in a normal synchronous order. So first, we print go1. Then we go into start and we print start1 and start2. Even though we're creating a promise, it doesn't matter. It's instantaneous to create it, and we don't wait for it. We continue with our code. It's still synchronous up to the await. When we hit the await, the start function ends, and we go back to the go function, to the caller function, to continue from where we stopped. So we print go2, and then the go function ends, and it all takes 0 time. After about 3 seconds, when the promise finishes, it wakes up and runs the second half of the start function, which was registered as a success callback, printing start3. Meanwhile, during those 3 seconds, the application stays completely responsive and the user can do whatever they want, including clicking the button again and starting the whole process in parallel. And that's how async await works. But hold on a second, bring back the code. What if I wanted to print the last message of the go function after the entire code in the start function has completed? In other words, what if I wanted to print the go2 message after start3, like any normal synchronous code? How would I do that? How would I know that start3 has completed? Well, we'll talk about that in the next video. See you then.